Students, so let us see what is there in the oblique projectile motion. Now, oblique projectile motion, the diagrams are in front of you. There is a name for this kind of projectile, and we call it oblique projectile motion. Oblique projectile motion. Now, oblique projectile motion can be defined as it is a projectile which is thrown at some angle with the horizontal. So, like let us say, I'm referring to this diagram now. Let us say you have thrown it with the initial velocity of u, and the initial angle with the horizontal is also known, like theta. So you will say that, okay, I'm throwing this thing at a velocity of like 50 meter per second at the angle of 30 degrees or 60 degrees. So what are the things that we have to note, isn't it? Yeah. Now, what are the things that we are going to find here? Number one is the range. So range is obviously the farthest distance that it is going to cover. This is the capital height h, like the maximum height which will be attained by the projectile, and the time of flight that will be there. For the students, those who are watching cricket game, no, like cricket matches, so you might be able to recall that the commentator is always commenting on, like, this is the longest six, this is the highest six, isn't it? So the software is using the same formulas to find what is the height that was attained by the ball and what is the range that is attained by the ball. So these are the same things. Okay, so in this question again, now what we do, again, we are not able to, like, we don't know how to deal with the projectile motion, so we will divide it into two parts, because we know how to deal with horizontal motion and the vertical motion. So let us say this is the instantaneous position, and this and this, these are the two shadows, you can say, or two things. Yeah, so they are moving. So this is moving with the velocity here in the horizontal direction, and this is moving in the vertical plane with the vertical direction. So this, you can call it like v, this will be vh, this will be vv, anyways, but we are not concerned with that, so no problem. So again, we are going to deal with the horizontal position first of all, or it will be better if we go for the vertical motion first of all. Vertical motion. So vertical motion, what is happening? Let us say we talk about this position, like this is the vertical position of this. I'm tracking that. So it was thrown earlier in the upward direction. And what was the velocity? Just a moment. The velocity, let me show you the component of the velocity. So this is velocity. We have created two different components for this. This will be known as u cos theta, and this will be taken as u sine theta. Okay, so I believe that you know how to divide the components, but because vectors are not there in your syllabus for physics, you might be confused. Okay, so like this is theta, so this becomes u cos theta, the adjacent side, and this becomes the u sine theta, the other side, which is perpendicular to that. That is u sine theta. So the same thing is replicated at each and every point. Like when we would be doing the inclined plane and the forces on an inclined plane, we will divide that for those forces into their components. We would be using the same concept. So this is u cos theta and u sine theta now. So now we are referring to the vertical motion. So vertical motion is like, let us say there is this point, it goes up. So it will go up, 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 and at this point it is going to come down to the same position. So for me, this point will be treated as the origin, because the motion started at this point. So this point is A, this point is B, this point is C. Just the way we did the vertical projectile motion, you must be remembering those things, isn't it? So this is completely the vertical motion, and we want to find the total time t. So by the way, we would be finding the same expression, and I would be invoking that also. So we can apply the SWOT equation here. Displacement is equal to ut plus half at square. So in the vertical position, so if you have some problem here, please try to refer to that video, which is I think like 2 videos earlier. That is the vertical projectile motion. You have to see that. I am applying the second method that I have taught in that video. Now in this sign convention will be chosen like this. So upward direction is chosen as positive because we have thrown the body in the upward direction. But the gravity is acting downwards, which is trying to stop the body from moving. So that is acting as retardation. So we are taking as negative. So the upward is taken as positive. Although sign convention is completely based on you can choose the other way also. There will be no problem. So this is going this and it comes back to the point C. It is starting from A and it reaches reaches back to the point C. So the total displacement is zero, isn't it? The total displacement will be zero. Now u, what is the initial speed with which the body is going in the vertical plane? That is u sine theta. So this will be taken as u sine theta. And what is the total time that it has consumed in the motion from going from A to C? So we will write that, okay, fine, it is the total time of flight. Let us have it t. Now, what is the acceleration? Throughout the motion, the acceleration is downwards, and that is gravity. So, dear student, whether the body is going in the upward direction in the first half, or whether it is going into the downward direction in the second half, whatever be the direction of the velocity, doesn't matter. The acceleration matters, and acceleration in both of the cases is downwards, and that is the action due to gravity g. So we will take it g, but due to the sign convention, we have to take it negative g here, and obviously we would be referring to the total time. So this is total time square. So this is what is there. And now from this equation, we will find the total time t. So now what is happening? This is 0. We can just take this one t common and that would be equated with 0. So you can say we can write it like this. This is negative term. So I have taken this to the other point. Like some students say that adding this quantity to both of the sides anyways. So it is this. So t and t gets cancelled out. From mathematical point of view, there is one solution for this quadratic equation, which is t is equal to 0. Obviously at t is equal to 0, the displacement is 0. So that is correct. So that we are getting rid of this. But anyways, so from here we find that the capital T can be written as twice of u sine theta divided by g. So this is t. This is the total time of flight, the time for which the projectile was in air. Or you can say, like if we take the example of cricket, so I can say that it is the time for which the ball was in the air. So this is the time t, 2u sine theta divided by g. I am going to relate it with the formulas that we have driven um, um there in the vertical projectile motion. At that time, like in this case, there was a direct formula that we found, and that was 2u by g. So I was remembering that. Okay, so even if you remember it, you can directly apply this formula. You can say that I know that the formula is 2u by g, and here the u is actually not u, but it is u sine theta. Just plug that value in, and in this particular case you get 2u sine theta divided by g. So if you remember this formula that we derived in that vertical projectile motion, you can directly use this formula. You can directly reach to this conclusion that t is equal to u sine theta by g. So this is the total time of flight. Okay, so having found this total time of flight, let us move to the range now. And the range, I can just write it here only because I think the space is enough, or I'm going to rub this. Yeah, because the formula, we have it here already. Okay, now range. Now you see, what about the range? So for the range, we would be concentrating on the horizontal motion, and we know that the acceleration in the horizontal direction is 0. So the velocity is not changing, the magnitude is the same, even the direction is the same. So the range will be equal to, like we can just say, distance is equal to velocity multiplied by time. So the distance will be taken as the range. Velocity is always going to be the horizontal velocity. But what it is now, in this case, it is u cos theta. So we will say that this is u cos theta. And what is the time? Time of flight, we have just derived it here. So that is 2u sine theta by g. 2u sine theta by g. Yeah, this is the equation. So you can just remember it. There will be many ways, like u square twice of sine theta cos theta divided by E. You can remember the range like this also. I remember the formula like this because otherwise it becomes confusing for me. So this is the formation that I remember. But anyways, there is another formation that will be written in your books if they are written. So what is that? Like there is an identity. There is a formula in the trigonometry that you might have studied in maths AAHL. Sine 2 theta is equal to twice of sine theta cos theta. So the formula becomes u square sine 2 theta divided by g. So this is the range, and here we are. We have the formula for us. So the range is u square sine 2 theta divided by g. Okay, so now we know the range also. Now we know the time also. So the only thing left is the total height that will be achieved. So who is hitting the highest six? Let us create a formula for that now. Okay, so this is done. I would be erasing this thing now, and we will go for the total height. Oh, I can't erase everything. Sorry. Uh, Let me erase this. Okay, I'm taking examples from the cricket, but these laws they are valid on the soccer game also for all the students, those who enjoy soccer, no problem. Okay, so let us go for the height now. What is the how to do it height? Again, we would be concentrating on the vertical motion again, and you can use the formulas that we have derived um, for the vertical motion, or you can apply the Suvat equations also. So u sine theta is here and it is going up. I think the formula was u square by 2g. Yeah. So u square by 2g, you can substitute the value u sine theta. So you will get u square sine square theta by 2g. But anyways, let us see. So in the vertical motion, I am going to apply v square minus u square is equal to 2as, because from A to B, at B, the final velocity is going to become 0. So this will be 0. U square is u sine theta square. Gravity is negative g. And the displacement that you go up, that is h. So that will be taken as positive h according to the sign convention, because this is treated as the origin and it is going up. So upward is taken as positive here according to the sign convention. This negative and this negative is over. So clearly the capital H is coming out to be u square sine square theta divided by 2g. If you can remember the formulas, you can directly apply the formulas at least for the paper 1. So that becomes really very easy. So H is equal to u square sine square theta divided by 2g. This is the formula for capital H. In the case of only vertical motion in the previous video, we found that H is equal to u square by 2g. And so in this case, it was u sine theta. You could have directly applied the formula. It will be u square sine square theta divided by 2g, and you would be getting the answer. So this is how we do this. Um, okay, these are the three main things that we cover here, but there are a couple of other things also that I'm going to tell you now. So, what are they? Some fun facts regarding the projectile motion, you can call it. Okay, so the point number one is uh, range is found to be maximum at theta is equal to 45 degree. How? We don't care about that because calculus is not in your syllabus, but otherwise we can use this also, like the range is equal to u square sine 2 theta divided by g. To maximize this, sine should be maximized, so sine 2 theta should be equal to 1, but we don't care about that. No problem, you can just remember it like theta is 45 degree. Okay, that is why I'm not going into details here, but if you feel like going, sine 2 theta is equated with 1, because you can't change u, you can't change g. Maximum value of sine would be resulting in the maximum value of the range. That is this. Point number 2 is that for the range, there are two values of theta, theta 1 and theta 2, for which the range is found to be same. And these two angles are found to be complementary. Now, Complementary means that theta 1 plus theta 2 is equal to 90 degree. This is the relation. Like for example, if I say that there is case number 1, when I say that I threw this body at 30 degree, and in the case number 2 you threw the body at 60 degree, both of them would be resulting in the same range. Both of them will be resulting in the same range. So the range here will be, uh, yeah, it will be in the same range. So I can just draw the diagram here like this, and the other will be somewhat like this. So we can clearly see, like, and this is our experience, isn't it? Like if you have played with the ball ever, like you can throw it like this also, you can throw straight way also into the same position. So there are two angles, this and this. These two angles are found to be complementary and they have the same range. So these are a couple of conclusions that you can draw from these formulas, but that they are not written in the book. So there is a chance that IB would be asking you these kind of questions. That is why I'm telling you. Okay, so another last point, the point number 3 that I can mention here is that if you, let us say, talk about this here, this position. So these are the two positions, and I'm going to name these positions now. Let us name this position as, I'm calling it as P. This position I'm calling it as Q. So the position P and Q, they are horizontally at the same level. So the 2 points which are horizontally at the same level, they have the same velocities in magnitude. They have the same speed. So if this is V, so this will also be moving with V. This is also the same, which is VV. The only thing is this VV was in the upward direction. This VV is in the downward direction. The VH is anyways going to remain the same, even in the magnitude as well as for the direction. The velocities are not going to change. In the vertical plane, the velocity is going to be reciprocal. So this final velocity is same as this. So point number 3, so the P and Q, which are at the same horizontal level, they're at the same horizontal level, P and Q. So this is the velocity that you are getting. Clear? So the velocity will be same at any horizontal position. Yeah. From that, like we can make this conclusion also, like at this point it was you. So let us say, I'm again taking the example of cricket. So the batsman hits the ball. So you can just imagine the power, the force with which the ball is hit. When you are hitting, like even in the baseball, you are hitting the ball so hard, so that ball is moving with a very high velocity. So when it is going into the gloves of the person who is catching it, or let's say the player who is catching it in the cricket, the ball is moving with the same damn speed. Do you get my point? And at that time the ball is the person, the fielder, is catching the ball. It is moving at the same velocity. So this is you, this is also you. Okay, dear students, so this is everything about the oblique projectile motion. I think you might have enjoyed the video, but if there is any other feedback that you want to share, please mention it in the comment section or also on the WhatsApp. That is very important for me. Okay then, so all the best, and we would be moving into the next video now.